Hello everyone. In this video, we will continue to explain the content from the previous section. The following three attributes are related to collision, determining which objects can collide. Each rigid body can be assigned an integer collision group index value. Collision between two rigid bodies is determined by the rules comparing collision group index values. If the collision group index of two rigid bodies is equal and greater than 0, they will always collide. If the collision group index of two rigid bodies is equal, but less than 0, they will never collide. If the collision group index of both rigid bodies is equal to 0, or the collision group indexes are not equal, the detection of collision behavior no longer relies on the index value of the collision group, but uses the rigid body's collision category and collision mask to determine whether a collision should occur. The collision category is used to specify which collision classification a rigid body belongs to, with the category value typically using 2 to the power of n as the attribute value, ranging from 1 to 2 of the 31st power. There are up to 32 different collision categories available as shown in the table. A collision mask is used to declare which collision categories of other rigid bodies the current rigid body may collide with. The bitwise and operation result of a rigid body's collision category and collision mask. If non-zero means a collision can occur. If it is 0, then a collision cannot occur. For example, consider the three rigid bodies shown in the table, with collision group indexes all set to 0. So judgment is based on their collision category and mask. Looking at rigid body 1 and rigid body 2, the AND operation result of 1 and 3 is 1. 7 and 2 is 2. Both are non-zero, so rigid body 1 and rigid body 2 can collide. Then looking at rigid body 2 and rigid body 3, the AND operation result of 2 and 3 is 2. 3 and 4 is 0. Since it's 0, they cannot collide. So rigid body 2 and rigid body 3 cannot collide. The collision between rigid body 1 and rigid body 3 can occur, which I will not detail further. The default value for the collision mask is -1, as all bitwise slots of -1 are 1. Performing a bitwise AND operation with -1 and any power of 2 value yields the power value itself, which is non-zero, meaning a collision can occur. Here are a few tips on collision settings. For a quick calculation of bitwise AND operations, you can use the DevTools console tool and perform calculations with decimal numbers directly by using the AND operator to ascertain the collision relationship. Sometimes it's necessary to specify a common collision mask for multiple different rigid bodies. This can be done by computing multiple collision categories using the bitwise OR operation, resulting in a mask that allows for collision. The result of a bitwise OR is essentially the sum of the collision categories. If you wish to avoid collisions with certain rigid bodies, you can perform a bitwise exclusive OR operation with -1 on any power of 2 value, and then perform a bitwise AND operation with that power value. The result will definitely be 0, meaning a collision cannot occur. For example, -25 can exclude bodies belonging to collision categories 8 and 16 from colliding. That's all for the use of rigid body components. Thank you.